Hey, everybody. My name's Rob Solomon. I'm a cloud solutions architect at CrowdStrike.
And I'm Sam Herath. I'm also a cloud solution architect with CrowdStrike. And today we want to present to you the Cloud Native Application Protection Platform, CrowdStrike, CNAPP, and how we can protect your AWS infrastructure and the applications you deployed within that infrastructure. And AWS is the leading cloud computing company. It created this space about 15 plus years ago. And CrowdStrike is the leader in endpoint protection and protecting cloud workloads. And we want to make sure you understand the integrations between these two companies and how we can protect your infrastructure and applications you run with it. Here you're looking at kind of the journey we have seen between CrowdStrike in the application into the journey into the cloud. And you're looking at the world moving from IT SecOps to DevSecOps. So what that means is that everybody here is used to the idea that we were deploying in the data center, and the data center had its own guardrails and the perimeter-based security, and they deployed applications in that perimeter-based security and were able to protect that, and IT security and compliance had a lot of control over that process. But over time, about a decade ago, when the cloud became the cloud as we know it, at that point, people lifted and shifted these applications into the cloud. So what that meant was that the same apps you were running on-prem with that security perimeter was now moved into the cloud for scale, for cost factors maybe, ease of use, and understanding what cloud-based deployments are. And then around 2014, 15, 16 timeframe, Docker became the containerized, Docker containers became very popular, and Mesos and other type of microservices-based architectures became popular. And this is when you refactor those applications and move them as greenfield apps into the cloud. So we went from lift and shift to greenfield cloud-based containerized applications and deploy that in the cloud. And today, we are with cloud-native applications, right? That means that we are using Kubernetes as an orchestration platform, deploying those applications using GitOps, CI/CD tooling, whether you're using Code Pipeline or Jenkins or any other type of integration service, and then using infrastructure as a code, Terraform and CloudFormation and such. And basically, the approach to security changed from IT SecOps, which is that perimeter-oriented security, into DevSecOps. So the idea was that you have to protect the left, which means that in the dev time, you got to protect that environment, scan those images for vulnerabilities as you shift to the right and shield the right-hand side of that story in runtime. But what's important to understand is that whether you're in the IT SecOps world or in the DevSecOps world or in between, CrowdStrike has solutions to protect you wherever you are in your cloud journey. So the world is moving, but everyone's moving at different pace and different capabilities. So with that comes the challenges moving to the cloud, right? And we know this, but when we identify them, each one, what we're looking at is primarily areas like shadow IT. Here we are looking at not only SaaS-based consumption of services by your business, but also business want to move a lot faster than IT and compliance would allow them, right? So they want to go ahead and get an Amazon account, do some testing, and do agile deployment and to provide for their consumers, their customers, and partners. And that creates challenges. And these may not be malicious, but inadvertently, you would lead on to things like misconfigurations, right? Because the cloud is a complex environment when you're deploying hundreds of workloads in using Terraform or CloudFormation. You may not have the best security practices assigned to those as opposed to when you had a more defined perimeter in the data center. So with that, security inconsistencies come into play. Again, these are opening up doors into the back doors and the side doors, not as much the front doors in the security realm. And then, of course, the runtime threats. The adversaries are every minute, every second, every day, every hour, and they're nation-state actors in the current state we are in the world. that are attacking your infrastructure and your data. And they have organized crime involved in adversary campaigns and ransomware campaigns. And of course, we have our zero-day threats are discovered, advanced persistent threats are discovered, and then vulnerabilities. And this is an area that's very interesting because it's not only the vulnerabilities you know when you shift left and scan for those images, but in runtime, you might discover the packages you're running may have vulnerabilities in them that were recently discovered. So that becomes an issue when you run immutable infrastructure like containers or Kubernetes-based pods and EC2 Docker-based instances. And of course, the biggest challenge in the cloud security environment is the skill shortage, right? So we all hear AWS is introducing new services, new infrastructure in a rapid pace. It's fantastic, it's great, it's innovative, but you gotta learn each one of these services and learn how to consume them, how to provision them, how to secure them in your infrastructure. Hugely challenging, not only for the smaller and medium-sized companies, even for large enterprises, because new service, new way of consuming infrastructure becomes a new challenge to deploy it and secure that infrastructure and the company's data, which is the most important asset. So that leads to the threat landscape. And the three areas that we have identified from a threat landscape perspective is, of course, one is misconfigurations. We talked about that in a little earlier. And this is commonly identified as cloud security posture management. What that means is that when you deploy your infrastructure, you want to make sure that infrastructure is protected from the moment you deploy it with the proper security configurations and policies and compliance requirements. And that means that that is a consistent threat to your environment because adversaries are always looking for ways to attack that infrastructure if it's not configured and secured properly. So for an example, I think a few years back, you had the Capital One attack, fairly well publicized, well understood, where a web application firewall from AWS was misconfigured, again, inadvertently, not maliciously, and a threat actor used that misconfiguration to elevate their privileges into that infrastructure and exfiltrated millions of credit card data and customer data from that environment. So that's one aspect. The second one, of course, is the supply chain. And when we talk about supply chain, it's not only your manufacturing supply chain or distribution supply chain that we come across in our day-to-day lives. This is the software supply chain. So a software factory is building applications, deploying them securely, securing them against misconfigurations, but your supply chain applications like modules or packages you use in your environment potentially could be areas of threats to you. For example, a couple of years back, a nation-state actor, it's a well-known case in case of SolarWinds, where they infiltrated the upgrade module that was upgrading SolarWinds from one version to the other, and used that to basically infiltrate through a Trojan every time you upgraded the SolarWinds infrastructure. And it affected a lot of government, defense, and large enterprise entities as they went through that upgrade cycle. Again, it was a low and slow attack, but very effective because they used not the software itself, but the upgrade process to attack your infrastructure. And the third one on the cloud threat landscape, it's really important, is the runtime threats that are happening every day, every minute, every second, every hour. So that's where we see the APT threats, the ransomware campaigns, the nation-state actor campaigns, and against your infrastructure, and then vulnerabilities that pop up every day, every minute.
So as Sam was saying, the dynamic nature of cloud and the proliferation of microservices really expands your attack surface. So how do you create a secure environment in that sort of complex, dynamic environment? AWS simplifies that process by creating the shared security model, where AWS handles a large portion of the security. AWS is responsible for security of the cloud. And that's really all of the basic building blocks, all the physical infrastructure, the data centers. This is all stuff that customers no longer have to concern themselves with. But customers are still responsible for security in the cloud. And that means that the resources, the applications, the data that customers deploy in cloud environments have to be protected, and that's the customer's responsibility. So, what are we talking about? We're talking about encryption in transit, encryption at rest. We're talking about firewall rules, security group rules, patching, operating systems, upgrading packages, things like that. And even though customers are responsible for all that, AWS provides the tools. Now, CrowdStrike can help protect your environment, and that's really what we do best. So we're able to see your configuration in your AWS environment, as Sam mentioned, monitor for indicators of misconfiguration and provide guidance in securing those workloads. And we also have our Falcon sensor that you can deploy on operating system-based workloads on EC2 or in containerized environments to deliver that visibility and telemetry. And of course, AWS provides, through the API-driven control plane, the ability to really see and control everything in your environment. So with CrowdStrike, we're here to help you monitor your environment, your dynamic, multi-region, multi-account environment. We advise you on best practices for securing that environment, and we protect those workloads through our lightweight sensor and always scanning for indicators of misconfiguration and indicators of attack. And it really all starts with the Falcon Platform. So at the bottom are all of the different workloads that you might run. So these can be in AWS, hybrid workloads, but really anything that has an operating system. We can protect that with our lightweight Falcon sensor. Now, for those of you who are not familiar with CrowdStrike, our Falcon sensor is deployed with no reboot. It could be deployed in massive environments in a very short period of time. And that's the only infrastructure that customers need to operate on-prem, just that lightweight sensor agent. And that it provides a very minimal resource footprint and provides a steady stream of telemetry that we process in our security cloud. And I'll say more about that in the next slide. So all of that data, the analytics, the machine learning models that we use to process that data, feeds our team of elite threat hunters, security researchers, incident responders, who are always pushing that envelope to find the next zero-day attack. And with that expertise, with that knowledge, with that telemetry, we feed a portfolio of services that can be purchased based upon your particular requirements. And that can include focusing on endpoint security or our cloud security suite, vulnerability detection, looking at your patch status, identity protection, making sure that that your groups are least privilege, things like that. But it all starts from that one lightweight sensor delivers that telemetry. So we have data. In fact, CrowdStrike processes massive data sets. How do we do that? CrowdStrike is deployed on AWS. I mean, we built our solution on AWS. AWS provides us with that massive scalability, so we can scale up our storage to handle trillions of events, or 1 trillion plus events per day. We're able to scale up high-performance computing to run our behavioral analytics models, our machine learning algorithms. And we ingest data from millions of endpoints globally. We take all that data, we correlate it together, store it in graph databases which surface relationships between different elements. And by doing this, we're able to see patterns, like even before they've actually attacked anybody. We track over 180 adversaries. Again, as Sam mentioned, adversaries are defined by their motivations, by their tactics. So we're able to identify those attackers, see the latest tactics that they're developing. And anything that happens in any one customer is immediately brought into the threat graph and is used to make decisions for all customers and protect all customers. This is where the crowd in CrowdStrike comes from. We crowdsource that data. And this enables us to make 135 million indicator of attack decisions per minute and protect 1.5 billion containers per day. So in the cloud environment, as we said, it's a complex environment. And one approach won't handle all of it. This is, again, your cloud assets can be quite sprawling. So we really focus on a broad and deep security strategy. The agent-based protection provides deep kernel-level visibility in your workloads. And that is paired with our agentless visibility, which is provided through the AWS API event-driven infrastructure. So AWS control plane is API-driven. So we're able to see everything that happens, not only looking for evidence of misconfiguration, but also through EventBridge, through CloudTrail logs, we're able to see all of the activity, and we correlate all of that together in our security cloud. And finally, we, as part of our shift-left strategy, we have a managed image and registry scanning service. So all of that together provides that comprehensive top-to-bottom protection.
Thanks, Rob. So with all those capabilities we brought together, like the three things that Rob talked to, let's look at the Falcon Cloud Security platform, our CNAPP platform as a whole, and what we bring into play, right? So the agentless security is primarily focused on visibility. So without installing a specific sensor in any infrastructure you're running in AWS or in environment, whether it's EC2 compute or Fargate or EKS, we will give you visibility into indicators of misconfiguration, right? That's kind of the traditional CSPM we talked to. We've been kind of hopping on that messaging a little bit here. Configuration monitoring. So this is kind of preventing those back doors and side doors as much as the front door of attack into your infrastructure, surface-based attack, and any kind of lateral movement through that. Everybody's doing that. You're going to hear that message again and again. And AWS has some components of that. But we differentiate further from us beyond just the graphs and dashboards and reporting into what we call our behavioral indicators of attack, or IOAs. And that's a differentiating factor for us because we have that telemetry that comes from our threat graph that Rob talked about earlier. That is a huge benefit to going beyond just showing you have a bunch of misconfigurations against a benchmark like CIS or NIST or PCI or HIPAA. Here we are looking at misuse and behaviors like evasive action, right? Privilege escalation, things of that nature that we can correlate now against known MITRE attack framework, adversarial behavioral patterns. That's really important. Very few vendors even can talk to that and be a leader in the MITRE attack framework, understanding what those adversarial patterns are, because they're not in that business in the game of stopping breaches. That's where CrowdStrike comes from, looking at that adversaries, looking at that behavior, looking at that misuse, evasive action, and now correlating in real time and providing you that visibility into so you can take remediation action. And then, of course, we have the asset visibility. Again, everybody's doing that from a visibility perspective into the control plane, where the assets are running, what region, what VPCs and such. And then the fourth one is we have the CIAM. Rob talked about it a bit earlier. It stands for Cloud Infrastructure Entitlements Management. This is primarily identity analytics. It's a kind of a growing area that's coming up lately. This is where you have visibility into your IAM roles, groups, policies, users. And if you see any highly privileged roles in your infrastructure tied to your compute and services. So that gives you another layer of visibility. And all these things bring together without having to install any agents. You bring a level of visibility and monitoring into your infrastructure. Then, of course, we shift left, and that's where we talked to earlier. You do that image scanning in near real time tied to your CI/CD tooling and pipeline, whether you're using Code Pipeline or Jenkins or any other tooling that your DevOps people are using, folks are using. We will integrate that with the image assessment API in real time and clean those images before they're deployed through immutable and ephemeral container infrastructure, right? That's for applications. But shifting left is important, but so is shielding the right. And that's where the agent-based protection come into play. And with CrowdStrike's tremendous strength in endpoint protection, protecting those Linux environments and Windows environments, and having built sensors for the past decade or so, we use that experience now to protect your compute infrastructure, your multi-operating environments, multiple versions of operating environments, and then you protect not only your Kubernetes infrastructure from an EC2 perspective that's running on EC2 and pods and nodes, but also serverless using Fargate, whether it's ECS or EKS. So that's a huge advantage compared to some of the other vendors in this space. So it's not only the agentless, agent, and shift left. So moving on, here we are looking at the partnership as a whole. We talked about deep integration with AWS. We are running on AWS. We are one of the biggest consumers of AWS services and their compute. And then, of course, we have different compute services we support. We'll continue to add to, and you'll hear more announcement this week. And then we have the different service level integrations we do. And those integrations, Rob and I are going to go one by one in the slides to follow. The product set that we have here, the Falcon endpoint protection that protects your EC2 Linux sensors and Windows. Then we have the cloud workload protection, which is your Kubernetes infrastructure, whether you're using EKS or you're running your own environment. And then you have a Falcon Horizon, which is kind of the visibility platform. And all of these together make our cloud-native application protection platform, or CNAPP, which is kind of the Gartner term out there. And then that includes the CSPM, CIAM, and discovery. And then, of course, we are fully in the AWS marketplace. You can consume it, test it, provision it into your infrastructure. It's easy to use directly from AWS marketplace, every one of these portfolio products we talk to. And we are in the public sector. If you're public sector folks here, we are NIST compliant and also in GovCloud and follow all the US government compliance policies.
So as Sam said, we're going to go through some of these integrations and show you what they look like. So the first one, we've been talking about indicators of misconfiguration, behavioral indicators of attack, the agentless protection. That's Falcon Horizon. AWS Control Tower, for those who don't know, is AWS's multi-account strategy. So many customers may have hundreds of accounts and operating resources in multiple regions. So managing all of those assets together, AWS Control Tower provides that single centralized pane of glass, the ability to implement guardrails, deploy new accounts, deploy and customize new accounts. And of course, Event Bridge will capture all of the API events throughout all of your AWS services and run rules against them. So in this integration, when you're deploying new accounts, how to make sure that they're compliant with your security configuration, whenever you create a new account, that creates an event, create new account, which is captured by EventBridge. So that triggers a rule which will register your new account with the Falcon Cloud. Again, there's no additional infrastructure. Falcon Cloud is a cloud-based service on AWS. So when you register the account, then Falcon is able to run scans against your account. And when that happens, as soon as it registers, Falcon starts scanning your account from its configurations. It starts monitoring for any kind of anomalous behavior. Events are captured, AWS service events, captured, sent through EventBridge, and analyzed through the threat graph to see if any of them are indicators of attack or misconfiguration. All that information is surfaced and presented in the Falcon dashboard, web-based dashboard. So our integration with GuardDuty. GuardDuty is AWS's threat intelligence service that is fed by VPC flow logs, CloudTrail API logs, and DNS, Route 53 DNS logs, and some other information as well. CrowdStrike, as a trusted partner, also provides indicators of compromise threat feed to GuardDuty, which helps GuardDuty make some of its findings, deliver some of its decisions. And what do I mean by indicators of compromise? So you saw on the previous slide of the threat graph, there's also the Intel graph, which has information about who are malicious domains, malicious IP addresses, malware files, things like that are part of the indicators of compromise which are delivered to GuardDuty. So even for customers of GuardDuty who are not CrowdStrike customers, this is available to everybody. It's just part of the service and kind of an indication of a close relationship between CrowdStrike and AWS.
Thanks, Rob. So next, look at a little bit more deeper into the shift-left integration I've been talking about earlier. And this is kind of goes into two parts. One is our integration with our Falcon Cloud Workload Protection Platform, which is our primary protection in the containerized infrastructure with Amazon ECR, Elastic Container Registry. And this is where before we do kind of scanning on those registries, the enterprise teams, security teams, and compliance folks can create some image policies, right? The policies might say certain criticality or high CVE levels or any kind of mid-low notification type levels, and they define policy for not only for blocking, but also for understanding what's happening in your infrastructure. So once we define those policies from a vulnerability scanning perspective, then we would run them against the registries, in this case, AWS ECR, and you can have run against multiple registries, and then that telemetry from those registries would appear on our dashboards, or you can send them real time to your dev and security and compliance teams. So that's the ECR registry integration and scans against that, against policies you define on the Falcon CrowdStrike dashboard. The next one, of course, is the CI/CD integration we talked to earlier, right? This is where we use that same kind of policy, but we're actually running that scan now in real time in your CI/CD pipeline and essentially blocking any kind of deployment of images that are containing any kind of vulnerabilities or malware, right? So you use, in this case, AWS Code Pipeline, and the code pipeline has defined certain CI/CD steps within that pipeline. And if you go to the leftmost side of that story, it's the Git integration with your local Git into code commit. And the dev teams and DevOps teams have their own favorite IDEs they're going to use. And then from there, they tie that into AWS code commit. And the pipeline will, at that point, go into essentially building through code build and integrating. And at that point, you'll do some testing. And during that test cycle, you would call the image assessment API on the CrowdStrike side and assess the image for not only vulnerabilities on the base image, but also the software composition analysis. So you're looking at any kind of packages in that infrastructure that contains vulnerabilities on the code, not just the containerized Docker base image. And if you find any vulnerabilities, at that point, if the image fails, the dev team would have to redo and make sure the image is cleaned up before it's deployed. And when it's deployed, of course, it goes into ECR, and from there you can deploy through EKS, EC2, or EKS serverless, or ECS, which is Amazon's containerized infrastructure orchestrator, whether it's EC2 or Fargate-based serverless deployment. So that's kind of the cycle of tying image scanning or shifting left. We talked to both from an ECR perspective and CI/CD real-time scanning perspective. So next, if you look at, let's look at this is kind of the full cycle of that. Next, if you look at the actual dashboards, what they look like, we thought we'd show some of that and how that explains kind of some of the work some of the integrations we've been talking about earlier. So here, this is kind of the visibility dashboard we talked to earlier. It brings in both the ECR integration-based data as well as CI/CD integration-based image scanning. And I've highlighted a few things here for you to kind of further delineate. So you have critical vulnerabilities. These are per the policies for IT security and compliance. You identify what are those critical vulnerabilities and take remediation action. There's another one called malware here. That's really important. And this comes into play because we have the best and the largest threat feed out there as Falcon threat detection. And we detect so many file hashes out there. And if one of those files get embedded in your containerized infrastructure, maliciously or inadvertently, we will recognize that when we do a software composition analysis of those images. So that's important to recognize, not just vulnerabilities from a package perspective, but actual files that are malware files and hashes we would scan for. And the next one is runtime vulnerabilities, so in the container infrastructure. So this is where, when I said shift left, but you shield the right, this is the shielding right. Basically, you shifted left, you image scanned, and found vulnerabilities on the images, and you cleaned them up, and you deployed it. But then while you're running your immutable containers out there in EKS or ECS or wherever you're running them, you find that a new vulnerability was discovered in one of the packages you have deployed. And that becomes a runtime vulnerability at that point. So this is why it's really important to have that runtime capability across your compute and deployed infrastructure. And then, of course, we have CVEs, top 5, top 25 CVEs recognized in your infrastructure, where we can take quick remediation action and see why that type of CVE is coming up in your infrastructure more often. So again, it's another cleansing process of your software factory and software deployment. And if you look at the kind of the registry connections dashboard, we have a deep levels of registry integration. We support about 13, 14 plus, and continue to add as per demand out there. And AWS, of course, is one of the major ones, ECR. And this is kind of the registry page to say there's a connection, the connection is active, its credentials are active, and this is what you're seeing from a status perspective. And then you have the, how many images are processed through this infrastructure, ECR connection. And then, of course, if you want to add a new ECR connection or any other registry that you want to support, you would go ahead and add that very quickly, directly within the infrastructure, within the Falcon dashboard. The next slide actually is a little bit more details into the result set of what we find. Again, all this is reportable, all this is, we can fed in real time to your infrastructure, security operations environment. But if you look at a little bit more details on in this case, an Alpine-based base OS image, we would go click on that and would find the vulnerabilities. In this case, 9 vulnerabilities were found. That's base image. Then you move on to the 14 other vulnerabilities we found in the packages that were running within that base image as your containerized application. So it's very detailed software composition analysis on the image. If you drill down further, if you drill down further, I'm sorry, went backward there, you would find the the package itself and how many packages have that particular vulnerability. Now, these package vulnerabilities are related to the type of coding you've done, whether it's Java or Ruby or Python or JavaScript, and the vulnerabilities within those packages. So when you drill further into it, you will see that you are looking at vulnerabilities. In this case, a log4j, which is kind of well known now, a vulnerability we found. It's a Java package, and these are the vulnerabilities in that infrastructure, right?
So focusing in on our runtime integrations, a large proportion, maybe a majority, of successful attacks are launched against unmanaged instances. So making sure everything is protected is really one of the first considerations. Our cloud workload protection integrations help you do that. So with Systems Manager, AWS Systems Manager is AWS's service for managing large EC2 fleets in hundreds or thousands of instances. Our integration really starts from a Systems Manager distribution package, which provides all of the instructions for deploying the Falcon sensor across different operating systems, and also what happens after terminating those instances. So after creating that distribution package, when a new EC2 instance is deployed manually or automatically through an autoscaling group or through cluster autoscaler or Carpenter, each new instance fires an event that will basically trigger the Systems Manager State Manager. State Manager makes sure that the configuration of your EC2 instance adheres to whatever configuration standard that you create. So you create a new instance, that distribution package is invoked. A call is made to the Falcon API. And the Falcon API will deliver the customer ID. Customer ID is important so that all of your telemetry is sent to your account and correlated against your assets. Falcon API sends that back. The package is invoked and installed, and now your EC2 workload is protected. Now, if you scale down or remove an instance, that triggers another event. And this time, the instance itself is now marked as inactive. It's hidden, as an active instance in your platform. But all the historical data is kept for correlation or historical investigations and forensics. In the containerized environment, it's essentially the same, a little bit different. We support all manner of containerized environments: EKS, ECS, self-managed, Kubernetes, Redshift. In this particular case, looking at EKS, it starts with deploying the container sensor configuration using Kubernetes native processes, either Kubernetes operators or Helm charts, whichever you are using in your GitOps process. The Falcon container sensor, containerized sensor, is deployed as a daemon set. And what that means is that on each new host that's deployed, a single sensor pod is deployed on that host. Now that pod collects kernel-level activity. It's able to protect all of the containers on the host and the host itself. One other thing about that, the benefit of using daemon sets and Kubernetes native controller architecture. If anything happens to that pod, if it is accidentally deleted or intentionally deleted, the controller will detect that and it will automatically deploy a new pod. So it's self-healing. If you're deploying your containerized infrastructure on Fargate, well, you can't deploy a daemon set, because you can't interact with the host in that way. So in that sense, we have a container sensor that is injected as a sidecar in your Fargate pod, and it's able to protect only the containers in that pod. Again, the benefit here, using the Kubernetes native tooling to fit seamlessly in your GitOps workflows. The container runtime protection, so you can see anything unexpected that's happening in your containers, including newly discovered vulnerabilities, and the ability to automatically respond, as we'll look at in just a moment. And container drift prevention. So the best practice for containers is that they are immutable, that you're not changing them once they're deployed in production. So our sensor will detect new packages or applications that are installed, and you can optionally configure it to actually block that installation to protect your workload. So walking through an example of what that looks like, here is the Falcon console landing page. This is the main page on your Falcon console. And you can see that there's a section that shows the most recent detections. Now, you can click right in that detection, and that brings you to a detailed view of that specific detection. On the left, we provide a visualization of the process tree. So you can see exactly where the attack took place. You can highlight any of these processes to get information about it and the disposition of those processes. So looking at this specific example, we can see the host name, the private DNS of the host instance. There's a container ID, which indicates to us that this is a containerized workload. Now, we're drilling into this one process, this wget process, which should not be there. And we can see that that process was automatically killed. Now, this is without any additional configuration, no manual intervention. That process was killed. And we can scroll down further and see what the cloud account ID and the instance ID. Again, you might be running in a multi-account environment, so being able to focus your investigation to see exactly where the problem is really critical to save time and act quickly. And you can also see the specific command that was issued with that wget process. So we can see the malicious IP address. You can take that and create firewall rules based on that, as well as the malware file that it was trying to download. Now, right from here, you can drill down further, and you can also sort of zoom out and see more context. In fact, you can see the entire event timeline. Now, if you look at the timeline of the attack, again, really helpful if you're doing an incident response or investigation or collecting information to figure out how to protect your infrastructure in the future. We know that the wget process was already killed. Now, if we want to look at how this started, right, you can go right to the top and look at where the initial access happened, and we can see that that a shell, Dash, which is a lightweight shell, was deployed on your container. We know that that this Dash process should not be there. Falcon may not know that because it is a valid executable, but we can kill that process right from here because the kernel-based sensor is not only delivering kernel-level telemetry, but is also able to act on that and automatically respond to these attacks. Now, finally, we talked about the event stream that your sensors are generating all the time. That event stream is being delivered to the Falcon Cloud Security Cloud. Typically, that traffic would egress into public IP space. But if your organization has really strict compliance and needs to stay within private IP space, we have private link connections in multiple regions so that you can send that data through the private IP space. Provides secure connectivity, helps you maintain compliance, simplifies networking. You don't have to deploy edge firewalls and things like that.
Thanks, Rob. So next we'll look at a few of the integrations related to response and remediation. Again, we talked about different levels of integration. Now this goes more into how do you find things in your environment and get you empower your security operations team. So here, the first one is, of course, Security Hub. It's a tie-in to the SOC within the AWS infrastructure. And here we have a specialized application, a containerized app. We call that the Falcon Integration Gateway, or FIG. That gateway essentially can be run as a containerized app, Docker or EKS or ECS or Fargate, doesn't matter. And once you deploy that, that app will essentially tie into our event stream API, which brings up all those events from detections across the enterprise. So from there, with that event stream API integration with the FIG, the integration gateway, we would delineate the AWS-related infrastructure and compute and essentially figure out the incidents that we need to push towards Security Hub. But with that, we also need to transform those events into the ASFF format, which is what's recognized, the schema that's recognized by Security Hub. And you would do that to change those images into that format. And then from there, after we publish to an SQSQ, a Lambda function will pick that up and find where the particular detections are happening in the AWS infrastructure, where it's running, and what VPC, what region and such, and then provide that to the Security Hub environment for your SOC analysts to review and take further remediation action. The next integration is with the Falcon X threat intelligence and how we can integrate with, for example, the AWS network firewall, which is again another layer of integration with threat intelligence. And here you're looking at, you have deployed the AWS network firewall in your VPC environment. You have an EC2 instance, for example, running the CrowdStrike sensor, and it potentially could visit a malicious site. And at that point, because you're running that sensor, you're able to immediately stop that breach from happening. And at that point, we would send that information related to that malicious visit to the Security Hub environment, so the SOC analyst can take remediation action, whether it's manually or they can automate that process where a Lambda function basically updates the firewall rules with a block list, and then any additional instances that are running that may or may not have the CrowdStrike sensor can also benefit from that incident we found and fed into the SOC environment. Again, it's up to you how the operations work, and it's tying into updating your network firewall rules. The next integration we are looking at is with, again, the threat intelligence with S3 object store. Here we are looking at a process where you store hundreds and hundreds of thousands or even millions of objects in your S3 infrastructure. As you store them, we would have a Lambda function that integrates with our threat intelligence, go ahead and finds any kind of the file hash-based threats, and also we would detonate that object within a sandbox environment. If you find any kind of malware with that entire process, both threat intelligence and detonation, then we would go ahead and delete that file, and as a result would send a Security Hub event back for the SOC to take action on. So that's kind of those integrations with both the API with Security Hub and then the threat intelligence with AWS Network Firewall and S3.
So just some key takeaways. AWS provides a well-architected framework, and one of the 5 pillars of that framework is security. So AWS CrowdStrike helps you provide that well-architected security by providing top-down, bottom-up visibility across all of your resources. We help you shift left by providing a managed image scanning security service to prevent vulnerabilities from entering your production workloads in the first place. We integrate seamlessly with your containerized workflows, your infrastructure as code, GitOps, workflows. We leverage the API-driven control plane of AWS to provide that broad visibility of what's happening in your environment overall. And we provide runtime security, that deep level of visibility into your running workloads. Part of that is our next generation firewall, next generation AV, excuse me, which goes beyond signature-based detection and uses behavioral analytics to detect fileless and zero-day attacks. CrowdStrike delivers security across the entire cloud lifecycle.